Hi, my name is Wayne Odegaard with Aviation Laboratories, and today I'd like to speak really briefly about hydraulic fluid and hydraulic systems. What we'll start with is talking about the basics of hydraulic system. Most of us are familiar with hydraulic systems of big cranes, pieces of equipment, all the way down to small things. We could even consider our heart to be a hydraulic system because it's a large area that's pushing fluid into a smaller area. If we look at it like this, these systems here that I've drawn on the whiteboard, they all follow Pascal's law. Everything related to hydraulic systems follows Pascal's law. Pascal's law basically says that the force applied divided by the area will give us the amount of power in a system. So I've drawn these two systems on the whiteboard. They're both simple systems, but I wanted to show you just very quickly what how Pascal's law works. So if we said it out loud, Pascal's law would be a pressure change applied to a confined fluid is transmitted undiminished to every point on the fluid. What that means is that because fluid is not compressible, you can't compress fluid. Therefore, all the pressure that's applied to it will be transmitted throughout the system against the walls and against whatever it's pushing, right? So if we push down on this plunger here, all of the pressure and the force that's applied up here will be transmitted throughout this fluid system. And because these are fixed, the walls are fixed here, it will push up on this piston here. The amount of force applied there is the force divided by the area. So the area of this piston and the area of this piston. We can think of those as area 1 and area 2. Let me take a step back just a little bit though first. This is a simple plunger system. If we think about this like a syringe, we could push the wider part of the syringe and we see that a very small amount of pressure gives us a pretty fast and high output. So we can apply a small amount of pressure and we get a high output through the small orifice at the other end of the plunger. The same kind of applies here. If we put a small amount of force here, it will push this piston down this way. We can also reverse that. If we put a small amount of pressure here, we can push the piston back that way, which is the small amount. If we come back to here, if we put a small amount of pressure pushing down here, that will transmit up and push this up here. This is the way it works. The amount of force divided by the area for this is equal to the amount of force divided by the area of this side. Now, you may think, well, gosh, it seems like we're getting something for nothing, right? We push just a little bit here and we're getting all this force represented here. It's not quite true though, because if we push down on this, we also have to consider the volume. Remember, the fluid is not compressible. So all of the force that's applied to the fluid, it's not going to compress it. It's in fact going to push it up here. So if we push all the way down here, that may only fill up this much. So the equivalent downward force here will drive this up a small amount. So for example, if the downward force here were 100 centimeters, the upward distance here might only be 10 centimeters because the surface area is very small here, but the surface area is like 10 times that on this side. So we're not really gaining anything. It's not some magic trick to gain powered force. In fact, what's happening there is that we're applying a lot more distance here with a small amount of force that gives us a large amount of force here, but a small amount of distance. If we use Pascal's law, we can calculate how much upward force we'll get based on the downward force and surface area here by using this formula here. The amount of force is divided by the ratio of the areas of these two plungers, these two pistons, multiplied by the downward force here. Effectively, what we're saying is that because of the small surface area here relative to this surface area, we can apply less force down, but we have to travel a greater distance to get more force up, but a very small amount of travel here. So that's kind of the way Pascal's law works. So, how does that translate into a hydraulic system? Well, let me get rid of this from the board and draw an actual system, and we can kind of see how this all plays out.